After performing the experiment, these are the sample results of what you have to take. Okay? In the case of ammonium nitrate, the initial temperature is 20.0. The final temperature is 18.0. What is the temperature change? Now, temperature change is delta T. Delta T. Delta T means what? Temperature change. Whereby delta T is equal to T2 less T1. T2 is the final temperature. So this final temperature here is temperature 2. While initial is T1. Okay? So how do you get the temperature change? You say 18 less 20. What do you get? 2 degrees Celsius. Are we together? Don't write that negative. It is negative 2, yes. But it is a change. Just write what? 2. So our temperature change here, we write is 2.0. Don't write negative 2. That one is going to confuse you the time that at the moment you are going to do what? Calculation. So just write 2. You don't do what? Do not write negative 2. Let us go to this one. How do you get the temperature change? You say what? Delta T. Temperature change is equal to what? Final temperature less initial temperature. Whereby this is temperature 2, this is temperature 1. Now, subtract temperature 2, 22. Less initial, 20. What do you get again? 2. So the change is 2. So what do you write here? 2.0. So again, like other tables that you have been filling, the decimal mark is always there. And for my students like you, I encourage you to do what? To put it to one decimal place. And that decimal place should be 0. So instead of writing 1 or 2 or 3 or 4 or 5, in our thermometers, it is possible to get 5 here. But I don't want you to write what? 5. Just write 0. If you are seeing it is 22.5, almost 23, what do you write? 23.0. Are you seeing that? That way, you will not have a problem doing calculations. Now let's go to the first question. We have filled the table. We have done question 2, that is temperature change. And next question, which is question number 3, calculate the number of moles of ammonium nitrate and the number of moles of sodium hydroxide. Are we together? Yeah. How do you calculate the number of moles? Number of moles is equal to mass divided by molar mass. So that is question number 3. So you say here, number of moles is equal to mass, and that mass should be in grams. So divide by what? Molar mass. What is our mass? It is this mass here, 2 grams of ammonium nitrate. So this will be 2 grams divided by molar mass of ammonium nitrate, which is how many? 80 grams per mole. So grams and grams will go, and our answer will be 0.025 moles. Are we together? M-O-L-S. Are we together? Moles. I hope you are together up to that point. Now let's work out the number of moles of sodium hydroxide. We use the same formula. We'll say what? Number of moles is equal to mass in grams. We divide by molar. We divide by molar mass. What is our mass? 2 grams. Okay? 2 grams. What is our molar mass of sodium hydroxide? 40. So the molar mass of sodium hydroxide is 40 grams per mole. Up to that point, we took up ammonia. Very good. What do we get here? 0.05 moles. So those are the number of moles. Next question. Calculate the enthalpy change for the reaction. enthalpy change for the reaction. I hope you are seeing there are two questions in one. There's the question for ammonium nitrate and the question for sodium hydroxide. So you have calculated enthalpy, the temperature change for ammonium nitrate, temperature change for sodium hydroxide. So whenever you are doing the questions, do them in pairs. Are we together? So here we want to calculate the enthalpy change. So enthalpy change is delta H, that is enthalpy change, is equal to what? MC delta T. Are we together? MC delta T. Now what is M? M is equal to mass of solution. Mass of what? Solution. So for our case, we'll assume that our solution is 100 ml. So that 100 ml, assuming that density is 1 gram per cubic centimeter, then this is 100 grams. So it means our mass will be what? 100 grams. Okay, that is M. C is specific heat capacity. For our case, the specific heat capacity is that of water, which is 4.2 joules per gram per Kelvin. That is, if you are given like that. In most cases, you are given, and you are actually given. And then delta T refers to what? Delta T refers to temperature change. So this is temperature change. Okay? For our case, what was delta T? 2. So here we have a delta T being 2. So with this, we are already ready to work it the way it is. And I hope we have said delta H is what? Enthalpy change. Is equal to what? M, which is mass. Times what? C. What is C? Specific heat capacity. Specific heat capacity. And that specific heat capacity is that of water, which is 4.2 joules per gram per Kelvin. Okay? Now, let us now substitute delta H is equal to M. What is M? 100 grams. So this is 100 grams. Let us convert this 100 grams into kilograms. How many grams make up a kilogram? 1,000. So we divide by 1,000 grams per kilogram. Are you seeing that? So that you can get our answer in kilojoules. So if this one is in kilograms, this one again will be in what? Kilojoules. So you multiply by C, which is 4.2 kilojoules per kilogram per Kelvin times delta T. Delta T is temperature change, which you have got in how many? It is 2. Now these two, if it was in degrees Celsius, don't say, let me add 273 to make it Kelvin. No. A change is a change. If you want to get the same value, then you can convert these ones to Kelvin first. You say 18 plus 273, 20 plus 273, subtract, you still get 2. So whether it is in degrees or it is in Kelvin, you get the same 2. But don't add 273 to convert it into Kelvin. Are we together? So we multiply by 2, you say that one is 2 Kelvin. Now what will happen? Kilogram will cancel kilogram. Gram will cancel grams. So your answer will be in what? Kelvin will cancel Kelvin. Your answer will be in kilojoules. Are you seeing that? So what do we get here? 0.84 kilojoules. So here we get 0.84 kilojoules. At this point, this is what? This is heat change, not molar heat change. Are we together? Now to get the molar heat change, you'll come here and say, how many moles are these? 0.025. So these 0.025 moles are producing this amount of heat energy. Now you ask yourself, what about 1? Are we together? So you say, if 0.025 moles gives us how much? 0.84 kilojoules. What about 1 will give us how many? Now you carry out cross multiplication. 1 times 0.84 you divide by 0.025. So it will be what? 1 times 0.84 divided by 0.025. What do you get? Yes? 33.6 kilojoules per mole. Are we together? We must put aside here either positive or negative. Positive or negative. How will you know whether you are putting positive or negative? Now, if the initial temperature is higher than the final temperature, then that one is positive. In other words, that is an endothermic reaction. In other words, if the final temperature is lower than the initial temperature, are we together? That is what? Positive. So this one is positive. We are going to talk about that one more when we are going to look at the difference between endothermic and exothermic reaction. Are we together? Let's go to this other one. We do the same thing. Delta H, enthalpy change, is equal to MC delta T. Okay? What is our M? Our M is from the volume. 100 ml is the same as 100 cubic centimeters. So this is the same as 100 grams. So our M is 100 grams. We divide by 1000 grams per kilogram so that we can have our answer in what? In kilograms. Are we together? We are converting grams to kilograms. Now what will you have? This one will go with that will go with that. So you'll have 0.1 kilograms. C is 4.2 kilojoules per kilogram per Kelvin. That is C. And then lastly, delta T is equal to what? You have already got it. What is it? 2. So you can write this one as 2 Kelvin. It doesn't matter. So let us work out delta H. We substitute. M is the same as 0.1 kilograms. You multiply by C, 4.2 kilojoules per kilogram per Kelvin. You multiply by delta T. What's delta T? 2 Kelvin. 2 Kelvin. So just like the other one, what will you get here? 0.84 kilojoules. Now let us convert. This amount of heat energy is released by how many moles? 0.05. So you come here and say, if 0.05 moles is giving us 0.84 kilojoules, what about 1? It will give us how many? How many? Are you seeing that? So if you do cross multiplication, so it will be 0.84. 1 times 0.84, we divide by 0.05. What do you get? 16.8. We get 16.8 kilojoules per mole, because we are looking for how many moles? For 1 mole. Are you seeing that? Kilojoules per mole. Now, we are here. We have said again, at the point of molar heat change, what do we need to do? We need to indicate whether the reaction is endothermic or exothermic. Are we together? Now, in this reaction, which temperature is higher than which? Initial or final?
Final.
The final temperature is higher than the initial temperature, meaning it was reduced to the surrounding, or heat rose. Are we together? If the heat rises, then it means what? That is an exothermic reaction. And what do you use to show the reaction is exothermic? You write a negative. So, there are 2 things I want you to be very keen. At the point of heat change, this is at the point of what? 0.84. You don't indicate whether it is positive or negative. Why do we indicate when it is positive or negative? At the point of what? Molar heat change. Molar heat change. Are we together? The point of molar heat change. So this is where you indicate whether it is exothermic or what? Endothermic. Lastly, that is question number 5. Write the thermochemical equation for the reactions that have taken place. Now, for this first equation here, what are we dissolving? Ammonium nitrate. So we are changing ammonium nitrate from solid state to aqueous state. So how do you show that? You write NH4, NO3. This is a solid. Do not write plus water. If you write plus water, you will never balance that equation. Where do we place water? We place at the point of the arrow. So you put your arrow here, then you write your water there. Water is placed where? Where the arrow is. Are we together? Yes. Very good. So this water is in liquid state. So you show now ammonium nitrate having been dissolved. So this one now has changed state. From which state? Solid to aqueous state or to solution state. Then you include the molar heat change. Where do you place the molar heat change? Not down here, but in front of the equation. Are you together? Yes. So you write here delta H is equals to positive 33.6 kilojoules per mole. And that is now the thermochemical equation. Now the next one is the thermochemical equation for the solution of sodium hydroxide. Now what will we do that? How will you do that? You do the same? The same. So it will be what? Sodium hydroxide solution. So solid. We are adding water and liquid. What do you form? Sodium hydroxide solution. Then what do we include? Molar heat change, which is going to be what? Delta H is equals to negative 16.8 kilojoules per mole. And that is your thermochemical equation. The whole of it. Where do we place water? At the point of the earth. Are we together? That's where you place the water. When the reaction is exothermic, which side must we put? Negative. When the reaction is endothermic, which side must we put? Positive. Are we together? Positive. The types of reaction taking place in the case of ammonium nitrate and the type of reaction taking place in the case of sodium hydroxide. Now, how do we know whether this reaction is endothermic or exothermic? That is what we want to know. Now, a reaction whereby the final temperature is higher than the initial, the final temperature is lower than the initial temperature is an endothermic reaction. So here, ammonium nitrate dissolution, this reaction is endothermic reaction. Endothermic reaction. We move to the second one. Sodium hydroxide. Is it endothermic or exothermic? Exothermic. So this one is going to be exothermic. Why is it exothermic? The final temperature is higher than the initial temperature. That's why I'm telling you, do not write here negative or positive. Because if you do subtraction, 13 minus 20 is negative 2. And because of that negative, you'll be confused. You'll think that this equation will end up with a negative. No, that's not the way you do. You just observe it with your eyes. Are we together? Yes. So this is endothermic reaction, and this is exothermic reaction. Now, let us look at the reasons why we are saying this is exothermic and this is endothermic. Here, this is exothermic reaction because temperature The temperature rises. Look, the temperature has rose from 20 to 22. Temperature rises. What about in the case of endothermic reaction? The temperature has dropped from 20 to 18. So here, temperature drops. Temperature drops. The synonym of drop is decreases. Okay? Temperature does what? Decreases. What about here? The opposite, the synonym of rises is? Increases. Temperature increases. Don't say increases. Temperature does what? Increases. Have you seen that? Very good. The other point, if we have said the temperature is dropping here, what does it mean? Final temperature is lower than initial temperature. So that's another point. We say final temperature is what? Is lower than initial temperature. I hope you are noting somewhere so that you can use for the purposes of revision. Are you doing that? Yes. Very good. What about here? Final temperature is higher than initial. Okay? Final Are we together to that point? Yes. What have we said about the final temperature in the case of endothermic reaction? The final temperature is lower than the initial temperature. What about for an exothermic reaction? Final temperature is higher than initial temperature. So here, 22 is higher than 20. What about here? In the case of endothermic reaction, final temperature is lower than initial temperature. 18 is lower than 20. That is how you get that. Then lastly, in the case of endothermic reaction, there's a decrease in temperature. There's something known as assistance in a reaction. Are we together? Yes. Assistance in a reaction is the reactants and the products in the reaction. So in the first case, where we are having endothermic reaction, the system absorbs heat from the surrounding. Are we together? So here you say, system absorbs heat from the surrounding. Okay? The system absorbs heat from where? From the surrounding. Are you seeing that? That's why the temperature is dropping. What about here? The system releases heat to the surrounding. Have you got that? Now, I want us to learn about this system. What is the system? We have said the system is the reactants and the products in a reaction. So we are having this one. Ammonium nitrate is reacting with water to give us ammonium nitrate solution. This was a solid and this one is what? A solution. So what is the system? Ammonium nitrate solid and ammonium nitrate solution. This is now what makes up the system. So in the case of the solution of ammonium nitrate, the system is absorbing this amount of heat energy. In other words, the reactants are having less energy. This one, which is in solid, is having less energy. But the product now, which is the ammonium nitrate solution, is having more energy. Why? Because it has absorbed heat which was in the surrounding. Are we together? In this other case, the system releases heat to the surrounding. Are we together? So what is our system? Sodium hydroxide in the solid and sodium hydroxide in the solution state. So it means by the end of the reaction, heat will be released to the surrounding. Are you seeing that? Let me just try to do it. You see what is happening. This is our thermometer. This is our thermometer. Now, if I take a solid, like for example this one, that is the solid. Now, I measure the initial temperature like this. So I just observe the temperature like this. Initial temperature before adding anything. Or I just use a smaller amount so that you can easily observe what is going on. So I pour this water here. This is water. It's about 100 ml of water. I've not measured the quantity of the solid. So I just want us to see whether there's absorption of heat or what? Release of heat. So the initial temperature here is 26. Can you write that on as initial temperature? That is now temperature 1, 26. And then I pour the whole of this solid inside, like this. And then I dissolve it. When you are doing that, make sure you don't hold this side. Why? It will be absorbing what? Heat from your body. Are we together? We start like this. Now, as we are speaking right now, the temperature is already at 14 and it is keeping on dropping. The temperature is already at how many? By now it is at 13. So we start like this. By now the temperature is 13, it has stood at 13, it has refused to drop. What was the initial temperature? 26. What's the final temperature? The final temperature is 13. So let us look at that case. The temperature is now 13, as you are seeing there. So what's the drop in temperature? Yes? 13. So initial, so that is T2 is 13.0, T1 is equal to 26.0, delta T is equal to 13.0. But it is a drop. So is that endothermic or exothermic? That is now a typical example of endothermic reaction. Are we get up to that point? That's a typical example of an endothermic reaction. Now, why did the temperature drop? We are having, we added some water, is it? So that water has lost that amount of heat energy. How many degrees? 13 degrees. So the system has absorbed what? Heat. Are we together? From the surrounding. That's why the temperature is dropping. So in the case whereby the temperature drops, the sign is positive. But there's a drop in temperature. If you do direct calculations, 18 minus 2, you'll get a negative here. But that will be very wrong. What you do, you need to see final versus initial. Final versus what? Initial. And then the value that you get here is positive, meaning the product, which is now ammonium nitrate in the solution state, is having more energy than ammonium nitrate in the solid state. Why? It has absorbed heat from water. The system has absorbed heat from the surrounding. What's the surrounding? It is what? Water. Are you seeing that? That's why the temperature has dropped up to that level. So if we were to perform the same experiment for which one? Sodium hydroxide. What will happen to the temperature? It will automatically rise. So that rise in temperature indicates that the reaction is exothermic. Why is the temperature rising? It means this sodium hydroxide is releasing heat into what? Into water. So our thermometer here is measuring the temperature of the surrounding, not the temperature of the system. Are we together? It is measuring the temperature of the surrounding. So if the temperature drops like in this case, it means water has lost heat to ammonium nitrate. If the temperature rises, like in the case of what? Sodium hydroxide. What does that mean? Sodium hydroxide is releasing heat to the surrounding, and therefore the reaction is exothermic. So when the temperature rises, the sign is negative. When the temperature drops, the sign is positive. And where do we place the sign? Is it at enthalpy change or molar enthalpy change?
Molar enthalpy change.
Molar enthalpy change. Let us stop there for today.